Topic 1.3, solving with logarithms. We're going to be solving logarithmic and exponential equations. Here are some timestamps. So, let's first talk about combining different laws. Our product law and difference law aren't only for two expressions. They can be combined with more than two expressions. So for example, this expression, where they all share the same base, we can rewrite as so. Now let's first simplify. And we can actually just rewrite this entire expression into one. Like so. This is really interesting, and it's really nice to know, as it allows us to work with more than two expressions when working with the product and difference laws. Now, let's evaluate this. But at first, you might not have an option to set custom bases in your calculator. Well, that's where the base change law comes in. So let's write as so. Log 5 to the 21 will be equal to log 21 over log 5. And with this, we can just evaluate, which will be roughly around 1.89. Now, let's look at this expression. At first, it might look a bit complicated, but we can actually rewrite this as so. Sorry, 11 cubed. And with further simplifying, we can rewrite this as so. Now, if we organize the x's like so, there's something interesting we can do. Well, this is of course going to be 36x, but we can write it like this. And now we can just use our logarithms. Our x will actually be equal to our logarithm. Our base is 36 over 11. And our anti-logarithm is 11 cubed over 2. Now, if we manually enter the calculator for this, which is going to be, is going to be a roughly 5.48. Now, let's look at this. They share the same base, and we can use the product law to solve for this. We can rewrite as so. X plus 2 times x minus 4 equals to 1. So this is log 7 of x squared minus 2x minus 8 equals to 1. Now, what's interesting is we have our base and our logarithm, so we can rewrite this as so. X squared minus 2x minus 8 equals 7. X squared minus 2x minus 15 equals 0. This is just going to be a very basic quadratic. As so. So we know x equals minus 3 or x equals 5. However, if we were to plug in x equals minus 3, we will learn that it does not exist. Some of these expressions would be incorrect. And so the only correct option is x equals 5. Now, let's solve to the nearest thousands. This one might look a bit complicated at first, but it's really just base change. We can do log 10 to the log 10, or just log to the x, over log to the 5, plus log x over, say, log 10, 10. Of course, this one cancels out. Now, equals 5. Now, what's interesting though, is we can factor this log x, which, when factored out, would lead to 1 over log 5 plus 1 equals 5. So log of x equals 5 over 1 over log 5 plus 1. And now, let's think about what we have at the moment. We have the logarithm and we have the base. So x is actually our anti-logarithm. We can write it as so, 10 to the power of 5 over 1 over log 5 plus 1. Now, if we were to evaluate this, this will be roughly This will be roughly 114.036, I believe. Now, let's look at the next expression. We're proving 2 over log 8. You get the point. We want to find log 4 over a as our denominator. So let's use the base change formula. We can rewrite this as log a for log 4a over log 4/8. Minus 4 over log 4a over log 4/2. We can rewrite this, change the denominators around, and we can get 2 log 4/8 minus 4 log 4/2. And because that's a shared denominator, it's going to be log 4 over a. Now we just have to prove this is going to be equal to 1 up here. It's pretty simple. This is going to be equal to log 64 minus log 4 to the power 4, 2, 4, 8, 16, which is actually going to be log 4, 64 over 16 is 4, over log 4a, which is going to be 1 over log 4a. Then we have this expression. We can also use the base change formula. Log a, 36a, over log 36, 6. We can change this around. We're going to get 2 log 36, 6 over log 36a, which is going to be equal to log 36 over log 36a, which is actually just going to be equal to 1 over log 36a. Now for this final expression, it's pretty simple. We can use the base switch formula. We know that log a of b is actually always going to be log b of a over its reciprocal. So we know that p cubed is going to be equal to 4 over p squared, such that p cubed equals 4p cubed equals p squared. 4p cubed minus p squared equals 0. We can factor out the p squared. We're going to get 4p minus 1 equals 0. So p equals 0, or p equals 1 over 4. Now, if we were to evaluate p equals 0, we would get a logarithm that is 0. But there is an issue if we look at this expression. 4 over 0 does not exist. So, therefore, the only possible solution is p equals 1 over 4.